In example 16, we're asked to prove that sine of 3x minus sine of x over cosine of 3x plus cosine of x is equal to tangent of x. I'm going to use the sum to product formulas from the previous page, and I'm just going to rewrite them here. I know that sine of x minus sine of y is equal to the product 2 times cosine of x plus y over 2 times sine of x minus y over 2. And in the denominator, I have a sum of cosines here. So I need to find a sum to product. And this is kind of like a difference to product. So we'll write this as cosine of x plus cosine of y is equal to 2 times the cosine of x plus y over 2 times the cosine of x minus y over 2. With these two formulas, I can now work with the left-hand side of this identity that we need to prove. Now this left-hand side is the only side I'm touching. I'm leaving tangent of x alone. I'm also going to define the 3x as my x and the x as my y. So this helps me with the substitution for the formula, and this should help modify everything to look like the right-hand side. Now, sine of x minus sine of y gives me in the numerator 2 cosine of 3x plus x over 2 times the sine of 3x minus x over 2. And in the denominator, I will have 2 cosine of 3x plus x over 2 times the cosine of 3x minus x all over 2. And now I can look at the numerator and denominator and decide what I can divide out. The 2 in the numerator and denominator as the leading factor I can divide out. And I can also see that cosine of 3x plus x over 2 and in the numerator and cosine of 3x plus x over 2 in the denominator will divide out. I am now left with a very convenient numerator and denominator. So I will go ahead and rewrite that now. I have sine of 3x minus x over 2, which will give me 2x over 2, divided by cosine of 3x minus x over 2. This will give me 2x over 2. Notice that the angles match for sine and cosine, which means I can rewrite this as tangent of 2x over 2, which reduces conveniently to tangent of x, which is what I wanted to show for this proof. I have now proven that tangent of x is equivalent to the left-hand side. So I have shown, as desired, that tangent of x is equal to tangent of x. Now this last little piece of information is kind of just extra. It's free. It's for free. So it could be helpful to you as you continue to work through identities and factoring, and that is knowing Pascal's triangle. We can find the value of a plus or minus b, that quantity raised to the n power, much faster, and use it to answer questions when the sum or difference is raised to a higher power without foiling, the long way. So let's take a plus or minus b raised to the 0 power and recall that that will give us 1. Also, recall that a plus or minus b raised to the 1st power will have coefficients on a and b of 1 and 1. Now, if I were to continue this pattern on, if it was to the 2nd power out front, a plus or minus b as coefficients would end up being 1 and 1, but the coefficient in the middle would be a 2. Notice that 1 plus 1 gives me 2. And also that if we split these into a triangle, this pattern continues on and on and on. 1 and 2 is 3. 2 and 1 is 3. We can bring the 1 down and the 1 down. And this represents a plus or minus b to the 3rd power. Now if we wanted a plus or minus b to the 4th power, we would have 1, 4, 6, 4, and 1 again as the coefficients. You can go ahead and try this. It just keeps on working that way. It's kind of cool. Also, it's interesting to note that the first diagonal is all 1s. The second diagonal is the counting numbers. The third diagonal is factors of 3. And I'm curious if you can find the pattern for the next diagonal.